Yes, what are we doing? ये जो सब भी कर रहे हैं, why are we doing that? We want to do which algorithm? Linear regression. And what does this mean, W and B? So basically my so how does my network look like? My network looks like how many inputs? We've talked about this, but so just X, and this is going to give me, so let us put this neuron, and this is going to give me a Y hat, and that Y hat is given as Wx plus B. This is all we are doing right now, okay? Since it is linear regression, we said you can take that mean squared error thing and it will work. What are gradients? Simply vectors, okay? And every gradient in this case passes through 0, 0. So, I mean what I am saying is that this function is the simplest to visualize. How does this look like, by the way? So, when j is 4, how does my concentric circle look like for j's value equal to 4? Right. So, you have to be careful here. J equal to 4 does not mean that the radius of my circle is 4. Radius of my circle is something else, okay? And in this good equation, it is basically under root of j, okay? All right. So, I think that is it. Now we start from here. So, we want to start our gradient descent from here. What was the equation, what was the algorithm for training? What were those 4 lines? Until convergence, compute j, compute grad j, and then you have to update, okay? So, I think I had written this equation for 2D as well, yes. So, this is what we have. So, this is what vectorization is. You will see a lot about vectorization in literature. In general, how will I do this? If I don't vectorize this equation is put inside a for loop, right? For all the variables, apply this. In vectorization, there is no for loop, there is just one vector. So, instead of these 2 equations, what we have is one equation. Let me call this vector, for example, vector W, let us say, equal to W minus alpha grad j. So, this one line takes care of, it does not matter how many parameters do you have, okay. So, all these are vectorized now, okay. So, now I think I have talked about a lot of things. You have to help me out. I want to go from here to the minima when j equal to w square plus b square. How do I do that? Yes. When w and b is 0. So, what do I do? See, my question is, now I will talk about both these figures. You have to assume that this is a bowl and not just a string. So, let us say I start here, but as I said before, I do not like to imagine being on the cost function, right. The right way to do is you are on this plane itself, okay, and at some point cost function might be above you, at some points cost function might even be below you, but MSE will not be so. Why? It is a squared function, at most it will go to 0, right. But the sum of squares will always be a number greater than 0 if the differences are not all 0. in which case you will have differences identically equal to 0? When all the points are collinear, and we are assuming this won't happen, that is too simple a case. Okay. So we start from here. This is a point W comma B. I want to go to minima. So at this particular point, what is the height? Assume somewhere here. Okay. And I want to go in if I draw it here, in this direction, but we are visualizing it here somewhere. So what do I do? Compute J. What is the value of J at this point? Whatever it is. Okay. So it is here. Now, if you see this climbing or descending hill analogy, what will you feel like? I need to come from here to the lower the slope. Okay. And this other analogy, what it talks about, you are on the same plane, you have to move in one direction. Okay. Which direction do I choose? Negative gradient. Okay. So that is what this equation captures, the update equation. Okay. What do I do now? I start from W comma B. What do I do? Use that 4 lines of training loop until convergence, right? So are you converged? Right? Let us start. Compute J. What is J? You have that value of J, right? Just plug in the values of W and B, right? Because it's a numerical method, you will start from somewhere. So just plug in the values of W and B. You get a value of J in that particular equation. Fine. What next? Compute grad J. This is grad J. In this case, it is very simple, we know. So what will be grad J in this case? Just 2W, 2B. You already know the values of W and B, so this is straightforward. So you have computed grad J as well. What is my next step? So this equation, this one, I update. Alpha is greater than 0, this guy is something, so I just update. Okay. Assume I have come from here to here, right, somewhere here to here. Will I come here, or I can also go here? Right. So we said it's line search. You will always be on this line. This is the best case that can happen to you. Right. You won't get such things in general. So you won't come here. You will remain on this particular line. So let's say I have come here. What do I do now? Has it converged? Right? So then come back, do that exact same thing by compute J. Let's say it is J here this time. Okay? So you have already come here. Keep on doing this until theoretically you reach 0, 0. When you reach 0, 0, what will be the value of gradient? 0, 0, gradient is 0. Gradient is 0, that means W comma B equal to W comma B older ones, because this term goes to 0. So when this term goes to 0, your parameters are not updating anymore, and hence convergence is achieved. So we stop there. Okay. Now, okay, that's it. By the way, you will never have convergence in mathematical sense, right? Because you are doing things on a machine that has a least count. So that is what it is. Let me see if anything is left. So you know how to. So let's say what happens if I start from here? If this is my W comma B, which direction I will go into? this one. Okay, so I'll move in this direction. What happens if I choose alpha to be very large? From here I might reach somewhere there, let's say. Okay, and in that case value of my next j will be greater than the current j. When will this happen, by the way? When will the value of my next j greater than the current j? So keeping this as center, make a circle here. If my update takes me to a point beyond that circle, then the value of j will be greater than my current value. Okay? So your alphas have to be small enough. I think this is it for this two variable case. Now let me ask you question for. So now let's say I have this equation. What will be my j? So this is the most general linear equation, linear regression now. What will be my j? Same as before, exactly same as before, right? So I will still have, give me that equation, j of w1 w2 all the way until wn comma b, this will be 1 by 2m summation I equal to 1 to m y hat minus y, and then I need to have I for example and then square. Okay. This is same as before, you will have square sitting here, w1 square, w2 square, w3 square, okay. And how does this thing look like? A ball shaped curve in n plus 1 dimensions. Why n plus 1? Because you have n w's and 1b, okay. So all the imaginations that we have talked about, all these geometry that we have done for 2 dimensions, that same thing will carry forward here as well. Okay, linear regression. Okay. Now, what is the output in case of linear regression? So we can again draw this. In case of linear regression, I have this line as my output, okay. This is the best in which sense? This line is best in which sense now? It minimizes the this distance, right? Distance on the y axis. If you minimize the distance that is perpendicular to this line, it becomes something else. What is that? Huh? No. Okay. So this is what it is. Now we come to logistic regression. Any questions until now? So help me draw the network in case of logistic regression. Now in case of logistic regression, now I won't do one case, two case, because we have already done it for linear regression. Now I start with just this. Y hat, and my y hat is given by. So now we have two parts to it. Okay. What are y hats in linear regression? They will be real value. Okay. What happens in case of logistic regression? You have classes. So how will my CSV look like? Let us say you have x1, x2, x3 all the way until xn, you have these columns. How will your labels look like in the simplest case? In fact, in case of logistic regression, labels will be 0, 1, yes or no, right? So you can have, so an example of this could be that, you know, housing price prediction. Now how do I convert that same housing price prediction to a logistic regression problem? Right. Right. So I simply say if price of house is greater than 20 lakh, 1, else 0. Okay. So you are not guessing the exact number. The only question you are asking is whether price is greater than 20 lakhs or not. Okay. So we start with logistic regression now. In logistic regression, your neuron has two computation parts. First one, it is linear, and from now on in this course, whenever I mention neuron, I mean this. Okay. So, and this takes activation or non-linear part. Throughout this course, we will use letter J to denote linear computation, and we will use letter A unless I change it at some point of time to denote non-linear. Okay. So what happens in case of linear logistic regression? I have Z equal to this is my linear part, which is same as, so this Z is same as y hat of so this Z is same as the y hat of linear regression, but in this case it is not. In this case, what is y hat? In this case, what is y hat? कर रखा है आप लोगों ने तो ये? Yes. So y hat is sigma of Z, and what is sigma? Sigma is, so sigma of Z is given as, right? This is what we have. Sorry, thoda sa tej. What is the question? The hypothesis function is that one. Right. Logistic regression? No, like the hypothesis function is that. This is the only one we have. So when you say logistic regression, this is the algorithm. Nobody stops you from having something else, but that won't be called logistic regression. Okay, but in general, my answer to most of the deep learning questions is you can do whatever you want, right? This is how the field is developing right now. You can do whatever you want. In the end, what is the goal of machine learning? Generalization. Okay, other than that, you want to find a function that maps input to output, and that function should generalize well, right? Because let's say if it generalizes only on my data set, then I can't really take it into the wild and apply it somewhere else. Okay, that is, this argument is precisely very centric to the fact of this responsible AI, regulating AI and everything, right? Because you were not talking so much about, software systems that much. Why? Why we didn't have something called regulating laws for software? Even though it would have been better to have them, but we did not have them. Why so? Huh? No. See, in traditional computer science, you would say this is my time complexity, this is my space complexity. You will talk about these things here as well. Even though in classes we won't talk about that, but you can talk about this because how much time it takes, how much space it takes, fine. In fact, here you also talk about how much money it takes, right? So, but in case of traditional computer science, you would say time complexity, space complexity, you would prove correctness, right? You would prove correctness that this algorithm works the way it is supposed to work. Correctness proofs, they are just not there, okay? Your machine will learn a function f and no other guarantees. Whereas in traditional computer science, when you wrote down quicksort, you can rigorously prove that this function, this algorithm, all it does is, if you give input an array, it is always going to give you a sorted array. You can prove it. Whereas if I make a cat recognizer, I cannot prove that this is always going to recognize cats, right? So no guarantees. Since no guarantees, I can't really trust your system. So let's say now if you make an AI system, so in fact this has happened in past. So like 5-10 years ago, there was this system in the US, there was a company doing it, I don't remember the name, but there was a company doing it. So they trained AI on faces, and just based on this feature, they were deciding whether a person can be offender or not. Okay? So just because somebody tried to do something fancy, calling it AI, it does not mean that should be acceptable in the society, right? Because कल को किसी को भी पहुंच जाओगे भाई तुमको अरेस्ट करने आया because my algorithm says so, and this is actually happening. This is called predictive policing. This is happening, but those are different debates. We don't go there. So, is this fine? If this is fine, then you have to tell me what will be my gradient descent algorithm? What will be my training algorithm in this case now? Exact same? Right. So exact same, I won't write it again, but you have to help me recall that. What was that? Until convergence. In fact, I'll get rid of this until convergence. How do you get rid of until convergence? See, until convergence is something you can't really have, because there will always be some small difference between your previous W and current value, right? You can't wait for that to basically go to 0, right? If you remember, if you subtract floating point 2 minus integer 2, right, they won't match. Have you done these kind of things in programming courses, right? For example, C. So you would think that mathematically these two quantities are equal, but when you actually write them into program, they are not, right? There might be difference of 10 to the power minus 10, let's say, okay? So those things will be here, and you don't really want to wait until then. So what do we do? How do I change this algorithm? So let me just write it again here. So it was until convergence compute j, then compute grad j, and then you have to update, and I am just writing in terms of vector, w equal to w minus alpha grad j and b equal to b minus alpha grad j. For some reasons we write these two things separately. W's are treated separately from B. So even these are also, both of them are vectors. Okay. So how do I get rid of this until convergence? Take some epsilon value, right? And then I had said that the most important graph in machine learning is this one, and you want some this kind of behavior. So what we do is, if this were a loop, how would you implement this? This clearly looks like a while loop, right? We convert this to a for loop by saying for epoch 1 to 100 or whatever. So we just get rid of this. Now if you reach to convergence in those 100 epochs, you are fine. So let's say if I choose epoch to be 5 and I still see a curve like this, so I stopped here. How will this curve help you decide that I should increase my epochs? Because it is far from being flat, right? So I should increase epoch. Let's say I increase it to 10 and I go somewhere here. What do I do in this case now? Still increase. Let's say I increase it to 100 and I see it something like this, and here it becomes, let's say, 25. Then from this particular figure I can see that I don't really need to go all the way until 100, maybe 30. Okay? This is the most important curve that gives us intuitions. Okay, chalo, next. So we have got rid of until convergence. From now we will be talking about epoch this. In theory I can still say this, but you know what does it mean. Okay. So these are the equations. And now since we have written this for logistic regression, you have to help me out what will be J in this case. I don't remember, you have to help me remember this. So what will be my J? So J of W1 all the way until Wn and B, this is question is why I don't want to use that same mean squared error. Why I don't want to use that same mean squared error thing? आउटलायर आएगा तो क्या दिक्कत हो जाएगी? जो करेक्ट पॉइंट होनी चाहिए थे क्लासिफायर वो करेक्ट नहीं होंगे दूसरी क्लास में थ्रेशोल्ड शिफ्ट मतलब जो हमने स्टेप करा है वो थ्रेशोल्ड एक से आगे शिफ्ट हो जाएगा. Okay. Anything else? Mm-hmm. See, what I want, if I want to convert it to a linear regression problem. In linear regression, my values were between minus infinity to plus infinity. In case of logistic regression, my values between 0 to 1. and minus infinity to plus infinity. Is there any difference between these two sets, or they have the same cardinality? Are these two sets the same or they are different? Which one is bigger? Minus infinity to plus infinity, right? They are the same. Okay. You can prove that both of them have same number of points. Both are uncountable infinity, right? So this particular interval has same number of points as this particular interval. How do you prove this?
We can map every point in the first one to the second one.
Right. Right? You can map every point here to here. But these opennesses are important. You make them closed, there is a problem. So these two sets are basically the same. Now, if you could use linear regression here, why can't I use simply here? Because I will get a real number between 0 to 1. If that number is greater than 0.5, I call it 1, because my labels are hard coded as yes or no. So labels in the end will be, my answer should either be yes or no. I might be right, I might be wrong, but my answer has to be either yes or no. Now, so this is real number, this is real number. Why can't I simply use, what was that, mean squared error? So we can use, nothing stops you from doing that, but we still don't use. What we use is, so help me write that equation. So you have things like y log y hat, and then other term will look like 1 minus y 1 minus y log 1 minus y hat. Why do you have hats inside? So one way to remember this is, because a lot of students make mistake here, they sometimes put y inside. Now y are your labels, right? Labels will be either 0 or 1. So either you will be talking about log of 0, which wouldn't make sense, and if you are talking about log 1, then that will make the term 0. So inside you have your predictions and not labels. Alright, what do I do next with this? Plus or minus? Right? So we have this one, but this I was doing for, so this is I am computing for ith example, right? So one example, so I need to have I for all the labels and all the predictions. So this is for one example, okay? This is for one example. How do I generalize it to everything? Summation. So I take summation I equal to 1 to m. And 1 by m, because we know averages are actually better than sum, right? For what reasons? It makes two cost functions, it makes two data sets in some sense comparable, okay? And then last thing that is missing is minus. Why do we use this complicated function and not simple mean squared error? How does log look like? The graph of so if this is my x and this is my log x, how does the function of graph log x look like? Yes. So what is log 0? Minus infinity, right? So it starts from here but never touches there. What is log 1?
0.
Any base?
Yes.
Something like this, right? So this is 0.0, this is 1. Log 1 is 0, okay? And then log does not increase that much. Now if you see, between 0 and 1, log has travelled from minus infinity to 0, right? So here it has travelled a lot of distance. Above, after 1 becomes super slow. Now what happens to exponent? It is the exact opposite of it, right? Exponent travels really slowly from minus infinity to 1, 0, 0, right? But after that it takes off exponentially, as we call it, okay? So both are inverse of each other. Now this is what? So how do I interpret this equation in terms of this? See, if, so let me draw this matrix now, 0, 0, 0, 1, 1, 0, 1, 1. If answer is 0, my algorithm says 0, right? What is the value of this term for that one example? Yi is 0, so yi is 0, this term goes to 0. Yi is 0, this term goes to 1, but then this term goes to 0 because it is log 1. So if answer is 0, I am predicting it to be 0, how much penalty do I get? 0. You have to give me for this one as well. If answer is 1, my prediction is 1, how much penalty do I get? See, 1 log 1 will be 0, and here you will have 1 minus 1. So that will give me 0, I don't care what is this, okay? So these two terms, when answer is correct and my prediction is that correct answer, I get penalized 0. Now what happens in this case? Answer is 0, I predict out to be 1. Minus infinity or plus infinity?
Yes.
So y hat was 0. So what do I do here? But y is 1. So this is log 0, that gives me minus infinity. What was this? Answer was 1, so 1 minus 1 gives me 0. So what is the error? What is the penalty? Minus infinity. What will happen in this case now? Plus infinity, karo ek bar. But they are symmetric. They are symmetric. So if this doesn't work, this guy works and so on. So this again will give you minus infinity. And that's why you have this minus sitting. That's why you have this minus sitting outside. Okay? So for every example, now these four are best cases in some sense. Your prediction will never be 0, never be exact 0, it will never be exact 1. It will be a number between 0 and 1. Okay? So all these guys will give you something between 0 to minus infinity. Okay? So all these will give you between 0 to minus infinity. Nobody is giving you anything positive. And if I keep on accumulating these negative things, how does my curve look like? How will my curve look like? Can I have a maximum value but not a minimum value? I will be able to have a maximum value, but there will be no bound on minimum value. I want to invert this. How do I invert this? Put a minus sign outside, right? So suddenly something that was not convex become convex. Why do you use this equation and not MSE? If you use mean squared error in this case, the resulting J is not convex. Since it is not convex, you don't want you don't want to make life harder by dealing with a concave function. You want to avoid it at as much as you can, but we'll see in deep learning all you get are complicated concave cost functions, right? So this is what we have. You use this cost function because it is convex. And what does it mean? What does it mean when we say a particular function is convex? It will have exactly one minima that will be same as global minima. So you are able to carry forward every goodness of linear regression to logistic regression just by changing the cost function. So now you are able to do this. Okay? This is convex, everything else remains whatever we had done before. Now, can anybody help me draw this thing? 1 upon 1 plus e to the power minus z. So, z, and on this axis I have sigma z. How does 1 upon 1 minus e to the power minus z become? So basically I am trying to draw this. Acha, what is the value at z equal to minus infinity? At z equal to minus infinity, it is e to the infinity, because minus minus will become plus. So 1 upon infinity becomes 0. So I am somewhere here, okay, almost touching to x axis. Now what happens at z equal to infinity? At z equal to infinity, I have e to the minus infinity, this term goes to 0, 1 upon 1 gives me 1. So at z equal to infinity, maximum I can have is 1. Okay. Now in the middle somewhere, can it become greater than 1 and then? So can I have something like this, for example? If z is 0, then what I have, e to the power 0, 1 by 2. So I have this 1 by 2 here, right? And this is something I want you to argue, that this won't go beyond these 2 points. So what you have here is something like this. I mean, this touches to 1, this goes towards 1, but will never touch to 1. So this is what it is.